in today's lesson then we're going to look at recurring decimals, and to begin with I'm going to ask you to convert these decimals into fractions. Now the reason we're looking at recurring decimals in particular is because they're a bit different to other decimals. A recurring decimal is a decimal that has a pattern that repeats. Okay, so you'll notice the three examples I've given you are three different types of recurring decimals. So the first one has just got one digit that's repeating, the second one has got two digits which repeat, and the third one has got a single digit followed by one digit which repeats over and over. And there can be various different types of recurring decimals that we can look at. Okay, so let's look at these then. So the first one I'm going to look at is 0.3 recurring. Now I'm hoping that you might recognise what that one is. So that little dot there means that that bit is recurring, and recurring just means that that number goes on forever and ever and ever. You would never finish writing it, so the dot there is really important. So what we want to do is we want to be able to turn that into a fraction. Now I've used this one to begin with because I'm hoping it's a decimal that you might recognise, so therefore you should be able to spot what the fraction should be, so you know that the technique that I'm using is working. Okay, so the way we do it is like this. To begin with, we're going to use a bit of algebra, and I'm going to say that A is equal to 0.333 recurring. Now we play around with this a little bit and we use a little trick, because actually having that recurring decimal going on and on forever doesn't help us. So actually what we want to do is get rid of it, and we can get rid of it by subtracting 0.3 recurring from another number which also has 0.3 recurring. You might think, well, how are we going to get that? Well, there's a simple way of doing it, and that is by multiplying by 10. So if we multiply this number by 10, well, if you multiply A by 10, you get 10A. And if you multiply 0.3 recurring by 10, you should know that 1 3 just comes over here. So we end up with 3.33 recurring. Now, because of the way that recurring decimals work and they go on and on forever, the fact that I've just brought one over here doesn't matter. These will have threes going on and on and on forever in both cases. So we haven't really lost one here because of the fact that it's infinity. It just keeps going and keeps going. So what we can do now is we can actually do a subtraction. So if we do 10A take away 1A, okay, we get 9A. So that gives us 9A. But what A is worth, A is 0.3 recurring, 10A is 3.3 recurring. So if we do that with this side as well, these bits cancel out with each other, because when we subtract the two decimals there, they'll just go. And we end up with 3 take away 0, which is just simply 3. And now all of a sudden the recurring decimal's gone, and we've just got 9A is equal to 3, which is just an equation which we solve. Now 9A equals 3, what do we do next? Well, we divide by 9, and if we divide by 9, we get that A is equal to 3 over 9. And our last step then is to simplify to the smallest possible fraction in its simplest term. So 3 over 9, because remember that over means divide, it's the fraction bar means the same as divide. So we look for a number that goes into both 3 and 9, and that is 3. 3's into 3 goes once, 3's into 9 go 3 times, and then we have a third, which is what we were expecting at the beginning. Now that technique can be used and adapted for different questions. So I'm going to look at the second example now. So we're going to do the same thing again. I'm going to call this A, but this one is slightly different, and the reason why this one is different is because we've got two digits repeating. So the two dots over 4 and 3 means that that's going to go 0.4343434343 forever, okay? So the dots, you put the two dots over the first and the last digit of the pattern which is repeating, if there's like a group of numbers that are repeating. If it's just one number, like in this example, we just put one dot. So because there's two numbers repeating, instead of multiplying by 10, we actually multiply by 100, because if we just multiplied by 10, then we would have 0.343434, and these two wouldn't match up, and then we couldn't subtract. So we need to multiply by 100. So 100A is equal to 43 point, and there you have your 4343. Okay? And now we do 100A, oops, take away 1A, so that gives us 99A. And if we do this side subtracted, we've got 43 take away 0, so that's just 43, and the 4343's just cancel out, and so we're just left with 43. And then to get our answer, we divide by 99, the number in front of A, and A gives us 43 over 99. Remember, at the beginning we stated that A was equal to our decimal. So if A is our decimal and we get a fraction, then that means that these things are the same. So in this case we've learnt that 1/3 is equal to 0.3 recurring, and in this case we've worked out that 43 over 99 is equal to 0.43 recurring. Right, the last example I've got here then is 0.8333 recurring. So this one's a little bit more tricky because of this 8. So what we do is we just adapt our method again. So this time what we're going to do is we're going to multiply first by 10, and that gives us 8.33 recurring. Now we can't subtract here yet because we're going to have a 3 with an 8, and that causes us a problem, although the rest will disappear. So then what we do is we multiply this one by 10. So overall we've multiplied by 100. Okay, so that gives me 100A. So I multiply that by 100, I get 100A. If I multiply 10A by 10, I get 100A. And then if I am just multiplying this one by 10, I'm just moving one more number over, so we get 83.3 recurring. And so what we end up with now is that the 3's can cancel. But this time what we're going to do with our subtraction is we're going to do 100A take away 10A. So if we do 100A take away 10A, we get 90A. And if we do 83 take away 8, we get 75. So we get 90A is equal to 75. Divide by our 90, and we get A is equal to 75 over 90, and then we have to cancel down. Okay, so if we do 5's into it, first of all, 5's into 75 is 15, and 5's into 90 is 18. And then you'll notice that 3 also goes into it. 3's into 15 is 5, and 3's into 18 is 6. So what we've actually ended up with here is 5/6. So that is how you convert a decimal into a fraction when we've got a recurring decimal. So you might find that some questions you have to vary it slightly. You can always multiply by 10 or 100 or even 1,000 or more than that if you need to, and use different combinations of these to subtract them. Remember, you're always looking for being able to cancel out the recurring decimal part, so you want to have exactly the same pattern like we did here and here and here, and then the method works. Now actually that was the more difficult bit, so what I want us to do now is I want to convert fractions to decimals. Okay, so for example, if we go back to that question we had just then where we had 5/6, so we found out that 5/6 was 0.83 recurring. But let's say instead this time you were given 5/6 and you had to convert that into a decimal. How would you do it? And this is what you would do. Remembering that a fraction bar means the same as divide, all you would do is a division. And the easiest thing to do actually is a bit of a long division or short division. Okay, so I'm just going to show you that now. So we're doing 5 divided by 6. So that means the 6 goes on the outside and the 5 goes on the inside. Now we know we're going to get 0 point something. So already you need to put a few zeros down. Okay? First thing you're going to do is 6 into 5. Obviously that doesn't go, so we're going to put a 0 up here and the decimal point, and we're going to carry the 5 over here. And then we say to ourselves, how many times does 6 go into 50? Okay, now the answer is it goes in 8 times, and actually 6 times 8 is 48. So we're going to put an 8 up here. Now 48 is 2 away from 50, so we've got 2 left over, remainder 2 goes there. Then we do 6 into 20. Now 6 into 20 goes 3 times, so we put a 3 up here. Now 6 times 3 is 18, so we've got 2 left over, which we can carry over here. Now we've got 6 into 20, and you should start to see now that there's a pattern. 6 into 20 goes 3 times, we put a 3 up here. 3 times 6 is 18, we've got 2 left over, we carry the 2. And actually that would just keep going. Alright? So, once you get to the point where you notice the pattern is repeating, you've got your answer. And then you would write 5, 6 is equal to 0.83 recurring, like that. Okay? Now, let's do one that's got a little bit of a longer pattern, just to finish off with, and that is 1/7. Okay, so I said to you that some fractions have got bigger sets of numbers that repeat, and the 7's definitely got that. So 1/7, set it up in the same way. We're doing 1 divided by 7, so the 1 goes here, 7 goes on there, and then we're going to need a few zeros. Okay? So we start off with 7 into 1. We know that's not going to work, so we're going to put the 0 there, and we're going to carry the 1 over. And then we say, what is 7 into 10? Well, 7 obviously goes into 10 once, okay, and 7 times 1 is 7, and how many is left over then to get to 10? Well, there's 3 left over, so that goes there, okay. So then we say to ourselves, okay, 7 into 30. Okay, so you've got to know your 7 times table. Well, 7 3s are 21, that's too far away. 7 4s are 28, so the answer is 4, that's as close as we're going to get. So we're going to put 4 up here. 28 is 2 away from 30, so we're going to put a 2 here. Now we say 7 into 20, so 2 7s are 14, so I think that's as close as we're going to get. So that must be a 2. 14, the difference between 14 and 20 is 6, so we need to put the 6 down here. And then we say to ourselves 7 into 60. I think the closest we're going to get is 56, which is 8. So we put the 8 here. And 56 is 4 away, so we need to put the 4 here. Then we say to ourselves 7 into 40. And the closest we're going to get there is 5 7s, which is 35. So we're going to put 5 here. Still, we don't have a pattern. So we've got 5 here, and what's left over? We've got 5 left over, because 35 up to 40, the difference is 5. Now we say 7 into 50, okay, and 7 into 50 is actually 7 itself. 7 7s are 49, so that's a 7, and we've now got 1 left over. Once we get to the point where we're going to have this same number, the pattern will start to repeat, because now it's 10, we're going to get a 1, we're going to have 3 left over, then we'll get 4 with 2 left over, then 2 with 6 left over, then 8 with 4 left over, and so on. So the pattern will repeat, and if you're not sure, you can keep going and you'll see that. Once you get to the point where the pattern starts repeating, you know you've got your answer. So then all you do is you just write it out. 1/7 is 0.142 2, 8, 5, 7, and you put your dot above your 1 and your 7. And the interesting thing about the sevens, if you want to go away and try some of this on your own, is if you try 2 sevenths or 3 sevenths or 4 sevenths, you'll notice that we have the same pattern of numbers just in a different order. So I'd recommend you go and try that out, because then it's a good practice to make sure that you can do this technique, but also you'll see an interesting pattern. So that's it. That's converting recurring decimals into fractions and converting the fractions into recurring decimals.